Hello, everybody. Hope you're having a good day without me. I am making this video just in case you forgot how to do average atomic mass. Hopefully, this extra practice will help you. So, this is topic 1.4, and up here we have our equation. It's ready to go. I'm just going to jump right into it. I'm not going to do every problem for you, but I'll do at least a few so you can follow along. So first off, it's real straightforward. It says calculate the average atomic mass of nitrogen given the following information. So here we have two isotopes, isotope number 1, isotope number 2 of nitrogen. Now, if they don't give us an exact mass, we would use this number here as the mass, right? That's why we name it by its mass. But they do give us an exact mass. If they do, we're going to use this one. And we're going to follow exactly what this equation tells us to do. So we're going to take the first isotope's mass. So we'll do that here. We'll start out with our open parentheses. We'll take the first isotope's mass right there, 14.003. And our equation tells us multiply by its percent abundance. That's what that means. And its percent abundance is just its percentage, and that's this right here, 99.63. We just match them up. So we're going to multiply by 99.63. Close that parentheses, and then we add. Don't forget, we have to put addition here in between each of these. That's a very common mistake. All right, now we just do the same thing, but with the second isotope. So we take the second mass, we'll do 15.00 times its percentage. Its percentage is 0.37. 0.37. Close that parentheses. Now the last thing our equation tells us to do is divide the whole thing by 100. So that's what we're going to do. Now, up here, don't forget, it says you must show your work for full credit. So don't just write the answer I'm about to give you. Show me your work, please. Show me you know how to do this. All right, so what do we do next? We need our calculator. Let's get our calculator in here. Cool. Don't forget what we said was we need a fraction. So we're going to do alpha y equals enter. Alpha y equals enter will give us a fraction. And all we need to do is type in exactly what we have right here. So I'm going to do the parentheses as well. So open parentheses, which is right there. Open parentheses, we're going to do 14.003 times 99.63, close parentheses, plus 15.00 times 0.37, close parentheses. To get down, I'm just going to push the down button to get to the bottom. Down button, there we go. Don't forget the last thing we need to do is divide this whole thing by 100. So we'll do that, 100. We'll hit enter, and we get 14.006689. That kind of makes sense. 14.006689. Now, if you put that, it was approximately 14.0 atomic mass units. That would be okay. All right, that's the first one. Awesome. Let's go down, down, down. All right, I'm going to let you guys, let's move this calculator out of the way. I'm going to let you guys figure out the second one on your own. It is similar. The difference on this one is this one doesn't give us an exact mass like this one does, right? So if there's no exact mass, what's my mass for this one? Well, my mass for this one is, let me get my marker back. My mass for this one is 28. My mass for this one is 29. Remember, the number at the top is the mass. So that's what you'll use for these ones. And here are its percentages. I know we didn't put it, but that's where the percentages go. All right. Oh man, where'd my trash can? Okay, cool. Okay. Let's check out number 3. Let's check out number 3 together. All right. Number 3 is pretty much the same as all the other ones we did. All right, that's good. What did happen to my trash can that was here? That doesn't matter. Okay, so we're going to use the same equation here. We're going to put our first mass. Now, again, they don't give us a mass, so we have to use this one here because that's all we got. So that's oxygen with a mass of 16. We're going to multiply that mass by its percentage, 99.76. Then we're going to add the next one. All we're doing is this one times that one, plus this one times that one, plus this one times that one. All we're doing. And that's all you got to do. 17 times its percentage, 0.04, plus, what's the next one? 18. What's its percentage? 0.20. Don't forget, all of this needs to be divided by 100. And we already said the easiest way to do that is to make a fraction. Let's bring our calculator back. Let's work that one out. Let's make sure we can see our numbers. Let's move our calculator over here so we can still see our numbers right here. All right, so again, alpha y equals, enter. We'll put everything in exactly like we wrote it down. 16 times 99.76. Don't forget the addition in between. 17 times 0.04 plus 18 times 0.20. All right, we push down and we divide everything by 100. We're going to get 16.0044. 16.0044. So our answer here is, oops, let's get marker back. 16.0044. Good job. All right. I'm going to let you all figure out number 4 on your own. Again, it's the same thing, except this time they do give us an exact mass. So let's use these numbers. Here we had 2. Here we had 3. Here we have 4. We're just going to add one more. It's not a big deal. All right, let's check out these ones at the bottom. Let me see. I forgot which ones I wanted to record for you. Let's do number 6 together. So this one says strontium has 4 stable isotopes: strontium 84, strontium 86, strontium 87, and strontium 88. Which is the most abundant? So for all of these, you need a periodic table. Don't skip number 5. Go back and do number 5 after you see the video. But what we need to do is we need to find strontium on our periodic table. So let's bring that up. All right, strontium is over here. And we see on our periodic table, strontium has an average atomic mass of 87.62. 87.62. So let's write that one down over here. Strontium has an average atomic mass of 87.62. So if we look at all of our isotopes, look, we've got 84, 86, 87, and 88. So it's asking us which of these is the most abundant if our average atomic mass is 87.62. The other questions here are pretty much asking you the same thing. Go look up the real average atomic mass on the periodic table and then take a guess which one of these is it the closest to. So really what it's asking us is, which one of these is this number closest to? And that's it. So 87.62, it's between 87 and 88. So it's going to be one of those. Is it closer to 87 or 88? That's right. It's closer to 88. So we're going to take a wild guess, and we're going to say that the one that is most abundant is strontium 88. If we wanted to be really technical, we do it like this. We could go SR, and we put 88 up here. Make sense? So like for this one says, given these two isotopes of iridium, and it gives you the atomic number 77, it gives you these two masses here, 191 and 193. Which of these two is the most abundant? Well, let's look back at our periodic table. Let's find iridium number 77. Here it is. So its average atomic mass is 192.22. So 192.22, is that closer to this number or that number? You take a guess, whichever one it is. You write that one down over here. All right, let's check out the last one. The last one should be pretty easy. Don't skip 5 and don't skip 7. Just those are the ones that you got to do on your own, okay? But the last one looks pretty easy. Look, because we kind of did this in our notes the other day. So here it says we got boron with a mass of 10 and boron with a mass of 11. Which of these two isotopes is more abundant? So first we got to find boron. We come over here. Here's boron. Boron's number 5, B. And it has a mass of 10.81. Let's write that down. Boron has a mass of 10.81. Now I know the first number that we see there is 10, but don't jump to conclusions. Look, it's actually really close to 11. And so from this number here, we can conclude that we have a higher percentage of 11. I guarantee you we're going to have questions like this on your test. So really what it's asking you is, which number is this closest to? 10 or 11? Well, it's closest to 11. So our answer is boron 11. I feel like y'all can figure the rest out on your own. So I'm going to leave it at that for you today. Let's cut that up. There's another video for your review. Miss Pope was nice enough to make that for us. So if you see her, tell her thank you. If you have any questions, feel free to message me on Schoology. I will be available, just not in school. And I am going to take this for a grade. If you all need to help each other out, that's fine. Help your group out, that's fine. Just make sure you understand how to do this for our test next week. All right, I'll see you all next time. Thank you.